now? Okay. Well, I think first of all, I would have to apologize because it's kind of an emergency that my family, my whole family is getting some COVID symptoms. So that's why I have to do this session online. For myself, I have really bad sore throat. So that's why I'm thinking maybe today's session will be a bit short and I will keep it simple. And yeah, hopefully it will go well. And yeah, let's get to the material by, I'll start sharing my screen. Okay. I hope you guys can see it. Yeah, it's just a, okay, this is the right page. Well, I have this syllabus already posted on our Blackboard, and it just located right here. And this is a student's preview. That this is should be something exactly what you will see on Blackboard. Yeah, let's go through the syllabus real quick. And it's hard to read like this, so I just open the syllabus here where it jumps out like this. Okay, the syllabus has listed like all the basic informations, like my contact information and where our lecture should be held if we are going to meet in person. And all the material will be posted on the Blackboard. And our office hour would be every Wednesday from 4 to 5. Actually today, I didn't see students come to the office hour, which I guess makes sense because we haven't have any material yet. And here's the Zoom meeting link if like for the next week or the following you have a question, and this is where you get direct help from me. If you think it's easier, you can come to my office. I think it's after the third week, starting from the fourth week. I will go to the office for the office hour. But for the first 3 weeks, while this university is having this soft open for all faculty and students, we'll just hold the office hour online. Well, I said here I prefer you contact me with via email, and please use your Gator email. Otherwise, I wouldn't be able to tell if this is students from my class. So yeah, please use the Gator email to contact me. I will try my best to reply as soon as I can, but please expect it will be within like 24 hours, and note that it will be like business hour. If you send me email on Friday, I may not get to it until Monday. Okay, and yeah, I just want you to plan accordingly if you have something really out of emergency or some important things. Please send me email, like plan well. And also I said I will use Blackboard to make announcements, and I hope you set this. I recommend that you set make the setting that you can receive those announcements immediately once I post it online, so you won't miss anything important. But if you have the habit of checking Blackboard every day, that's also fine. And if you have questions about the web assigned homework, So please use the Ask Your Teacher feature in WebAssign, and I have some details provided down below in the syllabus. And please do not use the Blackboard message to contact me. And the best way to get hold of me is to send me an email, and also like come to office hour if you really need some help. Okay, I guess like the following like the catalog description is just showing what we are going to cover. I'm not going to repeat this for you, and you can read it. And you will also get to know like the material as we go along this semester. And prerequisite, there isn't really some class as a prerequisite for this course. So as long as you are accepted in our master program, or you get our department approval to get enrolled in the class. Well, the learning outcomes, well, this is long. You can read it, and it just gives me give you the expectation that I'm having after you take the class, what you will learn. And some course material I mentioned here, the textbook is required, and when you get the access of WebAssign, you will get the online version of this textbook. And if you get used to a hard copy book, you can also order it. Well, just to save money, you can use this online version. And I will also add some material to the class, just for the enrichment, and I will just post it on the Blackboard, and will make announcement or let you know when we have lectures. I will see I posted something where you can take a look. And a great resource that I listed here is a free book about R. It's called R for Data Science. This is really a great book if you are interested in R and want to learn it. And at least for our class, we're going to use R for the lab. And we will have a little bit of R session when we go through the slides. But this is a great manual book that you can refer to if you want to learn R thoroughly. And here is the link where you can download R. I have opened this link actually here where you can download R, but I would definitely recommend that you download the R Studio, which this link would take you to this page, and it just tells you the R Studio is a very user-friendly interface that you can use R from it, and you will see example or like a very short walkthrough how to use R Studio later when we go to the slides. Okay, grading, we have this percentage. I'm hoping that you pay your effort during like the semester, not wait until the last week or so to just crash on the final exam. Homework have a really higher percentage weight on this grading, and also lab. So yeah, pay your effort during the semester. And if you have to be late, like on your submission of homework, if it's out of a formal excuse where you can provide me like the doctor's note or whatever other like formal reason that you have to be late on your homework, you can send me email. But if there is no reason that I just found you are late submitting your homework, there will be a penalty. So please pay attention to the due date and time to our homework, and I will announce it when I post the homework and give you an idea and see precisely when it is due. And there is no makeup exams, and the final exam grade will replace the grade of midterm if you miss the midterm because of excused absence. We will have a discussion board open on the on Blackboard. Yeah, discussion board, and if you have questions, you can just feel free post questions there, and other students can also jump in to answer the question, and I will also check the discussion board for see if I can help anyone. And the labs for the class, well, I'm thinking because we have right now we have only 8 students enrolled in the class. I'm thinking to have 2 students as a group to work together on the lab, because I think if you are the only one working on the lab and you have some debugging issue, it's really hard if you are by yourself. So that's why I'm trying to assign this as a group so that at least you can get some help. You can discuss with your team member on how to get this done. And the exams will be online with WebAssign. Well, I put this online because I think like, well, this can be changed. I have to like talk to the department chair, seeing if it's possible to do it online. But normally it's okay, because if we do it online, and you can use R and R Studio, where you can get more help. But this is because this is my first time teaching such a class, so there are some logistics I have to get through to make sure it will work. Yeah, I will update with you definitely before our midterm about the exam, but for now it will be online from WebAssign. And the letter grade, just the usual way. Okay, and how do you get help if you have questions? Either use WebAssign or use a Blackboard discussion. And also important is that you can come to the office hour if you need direct help. And here I wrote some detail on how to use this Ask Your Teacher WebAssign, and there are some other resources, like you can practice another version when you see a question on the WebAssign that you think you are not really confident for this type of question, that you can do another version, and that will help you to get better understanding and get used to the question. And there are tutoring sites, but it's not free. So again, if you need help, post question on discussion board and come to office hour. Okay, and these are some additional help that you can get from the Center of Math and Stats support. And here I listed some basic information for that center. Okay, so all different resources that you can get help. And this section is telling you our rough schedule, because it's subject to change if there is something happened or if we are kind of slow on our schedule, it could change. So these are the current tentative schedule we would see, and our final exam, for the final exam date, I would have to verify or make sure that I can get scheduled this to the first day of the final. And I listed some important dates here just for your reference. Yeah, and I think the rest is just some general policies that you can read if you have special need about either about this COVID or disability or whatsoever. You can read it. Okay, this is just a quickly go through of this syllabus. Well, okay. Let's go to the our slides. Okay, so this is a chapter 1. It's not necessarily be the same as the chapter in the textbook. So the textbook is there are just too much information. I would just get some very important information listed for the class that. So if you want to get more detailed on those definition examples, you can definitely go to the textbook. But for our lecture, I'll just sample some important points to list on the slides. Okay, let's get to the main content. So, what is statistics? So when people ask me or ask you what's your major or what do you study, you say statistics. Many people, they sort of know what is statistics. They might say it's related to math, and well, but not like exactly know what do you really mean by statistics. So when you explain to others, you can probably use the definition here. But it's sort of formal. Statistics are a way to make intelligence, judgment, and informed decisions when we do not have all the information and when there is uncertainty and variation. So it helps us make better decision, make intelligent judgment, and it's definitely based on data. We deal with data, we play with numbers, and that's what we do. And so I mentioned this uncertainty and variation. So I have an example here. If you could ask everyone on the planet their opinion, we would not need any survey. So if you just ask everyone on the planet, and if every light bulb lasts the same amount of time, we would not have to estimate their lifespan. That's where uncertainty and variation comes into play, because we would not be able to get all the information, all the data to ask all the people on the planet and measure every light bulb. So that's why we use statistics to organize and summarize the data we have in order to draw conclusions. So when we cannot get all the information, like do a census, we will just sample it, get some data, and we summarize the data, make plots, and do a modeling on it to draw conclusions from the data. Here it introduced the definition of population and samples. So in statistics, we study a population, which is a collection of persons, things, and objects. Like I said, every people on the planet, it will be a population. Or it could be, we say population, it could be like all the middle school students in the US. It's also a population. It's a collection of many things. If we can get information about the entire population, that's known as a census, as I mentioned. But if a census is not available, we take a sample, which is a subset of the population that we study to get information about this population. So because it takes a lot of time and money to examine an entire population, sampling is a very practical technique. Okay, I think I better give some example of, I mentioned like the middle school students, all middle school students in the US can be a population, but if we are thinking about a sample, it could be like the middle school students in Houston. So that's a subset of the whole population, right? And that's just a very simple example. Well, another important term we use in statistics, it's variable, which is the characteristics that we are interested in. Oh, I'm sorry. A variable, it can be any characteristics that we are interested in, and it can be categorical, and it can be numerical in nature. So it can change from one subject to another in the population. And some examples here, the type of car you drive, so it could be different for different person, right? The number of pets you have, the length of your commute, it definitely varies. So it's called a variable, and it measures the characteristics of all the subjects in the population. Okay, so when we talk about variables, there are some categories for the variables, like univariate, bivariate, and multivariate data. When we say univariate, it's just one variable that we're interested in. And bivariate is when you have two variables that we want to study. We just call it bivariate data. And it can also be, we have several more than two variables, we call it multivariate data. Okay, these are just some simple definitions. And another, okay, it's more terminology. It's we have quantitative variable and also qualitative variable. And quantitative variables can be discrete or continuous. Qualitative variable often called categorical. For example, the type of car, it can be sedan, it can be USV, and that is categorical, right? It's not numbers, it's just some categories. And this qualitative variable are often the result of categorizing or describing attributes of a population. And quantitative variables, they're always numbers, and the results of counting or measuring an attribute of a population. Discrete data can only take on certain numbers. Often there are integers, like the number of pets you have. It can be 1, 2, it won't be 1.5. And the continuous variable can be any value with some range of numbers. And again, the corresponding examples listed here. The type of car is quantitative variables, the number of pets, is a discrete quantitative, sorry, maybe I said it wrong. Type of car is qualitative variables, and the number of paths is a discrete quantitative variable. And the length of your commute, which is continuous numbers, is continuous quantitative variable. If all you want to do is summarize and describe important features about data you have, you use descriptive statistics. It primarily uses graphs and numerical summaries. But if you want to use the summaries to draw conclusions about the population, that is known as inferential statistics. And the bridge between these two, like descriptive and inferential statistics, is the bridge between these two is probability. We will discuss this probability more in chapter 2 to 5. Yeah, and before we can understand what a sample can tell us about population, we need to understand the uncertainty associated with taking a sample from a given population. There are more information about descriptive statistics here. And I think like doing a graph, doing like pie chart, bar chart, scatter plot, that you probably learned like how to do that in Excel. And for this class, we will learn how to do it, use R. Well, I mentioned this, do not use pie charts. Human brain are bad at reading them, but still sometimes pie chart is, you learn it, you learn the pie chart and just use with care. It's not really easy to use or to, it's not very friendly to human brain. Secondly, we have some notation. Here, like we normally use n to denote sample size. So if your sample have 10 observations, n would equal to 10. If you have two different samples you are discussing, you may use m and n to denote their sample size, or n1 and n2 to denote two sample sizes. So if you sample 30 people from one neighborhood and 25 from another, then n1 equal to 30 and n2 equal to 25. Those are the sample sizes for the two data. And as for a sample n observations of some characteristic x, each separate observation is denoted by x1, 2, x1, x2, x3, up to xn. And these numbers don't imply anything about their size and their ordering. It's just the way that they appear on your data set. The first one, you can call it x1. The second one, you call it x2. And so it does not imply like their size, their ordering. Okay, histograms, like that's one important tool in the descriptive statistics. It's a common way to display data. Well, I put some words here, but I think the best way is just to show you an example. This is a histogram. This is what a histogram looks like. And to read this histogram, we look at the boundary of each of the bar. And so this bar would represent the data value from 0.5 to 1, and how high each bar goes as the frequency, like here, like how many data points you have in this group. Well, I have this R code here, but I think it's better we just do this after I go through all the slides. Okay. Yeah, I think I changed my mind because, well, let's just because I have to share a new screen in order to let me see. Okay, I'll stop sharing this one and open another window. R. Okay, let me share share screen. Share this R screen. Okay. Hopefully you can see my R interface. Well, I know this could be a lot for you at first, but let's just quickly do it. I meant to do this after we go through everything on the slides, but now I think it's better I'll just do it here. Well, this is where I generate the data. Like when I do this, you will learn. Like I highlight this line. I put the cursor here. I press what you can highlight and click run. Okay. So I click the run, and then you see this command comes shows in the console. It just tells me I run this line. And the data I generate is like this, and it shows in the environment right here. Okay, and another way to run this line is I just put this cursor here and I press Command and Enter. It will just run again. It's just a different way of running this line. And so the data, if I want to see the data, I can either, well, I think I'll just highlight the data and click run. It will just show me the 100 data points that I generated with this command. So this is what the data looks like. And if we want to do a histogram, like this is the command hist to do the histogram, I'll just do this, highlight it and run it. So the plot will show here in this small window. And you will see yeah, this is why I said like RStudio is user friendly, that you have everything on this window, because I personally I do not use R directly, and I didn't show you like how to run R, use its original interface. So this is how you do it, use RStudio. Okay. Yeah, I would have to switch. Yeah, and I'd better mention this now. Like if you are not really familiar with R, I think the best way is to read the free online book and just do a couple of things on it. You will get a feeling of how this R work. It's easy to get into trouble that you get error. For example, if you like misspelled this mean, what is the mean, what is the standard deviation? Here, if I run this, it will give me an error, but sometimes it's really hard to realize, or sometimes the error message is not very informative. You cannot tell what is wrong. it can be really frustrating. And so I think a good idea is to get yourself a feeling of art, like just run a couple things with that online book, and it will help. You do not need to go through the whole book. It's too much, but do a couple of practice would help you for sure. Okay, I'll just go back to the slides. Share again. Okay. All right. So the measure of center. The center of the data is one of the very important descriptive statistics we want to do in the sample. Like we collect the data, say we collect the height of 10 students, and we want to where the middle of the data is. We want to know what is the average, or say the mean of this sample, and yeah, this is the most common measure of the center. Is the mean. It's just taking the average, and is often denoted by X bar. If we denote our data as X, then X bar would be its average, the mean of it. So this is just a sample mean, and it's obvious. And how do we calculate it? It's just a summation divided by the total number of subjects in your sample. And another common measure of the center is median. It's computed by taking the middle value of the data. So that is, you order the data from smallest to the highest, and then you get the one in the middle. That's the median. And if you have even number of data points, let's say we have 10, then the median would be just the average of the 5th and the 6th after you ordered the height of the students. Let's see. Okay, the median versus the mean. Something to note is that the mean can be very sensitive to outliers. So if we can use the median, if we suspect there will be outliers in the data, the median is more robust to outliers. And that means it's less affected by them. Well, example would be the income. So there are like really rich people. You can consider them as outliers, but for this case, if we're interested in the center of the income, we often use median because they are less affected by those really rich people. And again, here are some the R command to calculate the mean and the median. I will not rerun this, like switch back and forth from this R and our slides. So I'm just telling you, this is how you calculate the mean of the data. The data is I just generated with the R session that I just showed you. This is how you get the median. Well, and later I added an outlier to the data I call it data, and it will combine this data, combine this data vector with a single value 15. Previously we had the mean. So previously we have generated data with mean being 2 and standard deviation being 0.5, and mean being 2, it will just give us most data around value 2. But if we add another value to the data, say 15, it will be a big outlier comparing to the data we generated. So when I measure the mean of the new data, it becomes 2.145. Comparing to the previous one, it changed quite a lot, right? The median of the new data set becomes 1.99 comparing to this 1.98. It's get less affected. Okay, and if we look at this on the histogram, so basically I did the histogram again for the new data. And also this is another command to add a vertical line to this histogram, and I added the mean, a blue line, and I add the median as the red line. And this COL is just color, and this 2 and 4 represents different colors. So yeah, if you look at the histogram, it changed a lot, right? Previously, it has a kind of a bell shape, but now because of this outlier, it looks like this. We have one data point being here. And also, let's see, the quartile and percentiles. Okay. A common additional measure of the location of the data are quartiles and percentiles. And quartiles divide the ordered data into quarters, and percentile divided into hundreds. So if you are the 90th percentile, it means that 90% of the data is below you, and 10% of data is above you. So it divides the data into hundreds. The median is actually a special case of this. The median is the fifth percentile, and is also the second quartile. To find the quartile, find the median first. That's your second quartile. It's denoted by Q2, and take the first half of the data and find the median of that. Then that's your first quartile. So it divided the data into quarters. Yeah, similarly for the third quartile, you take the other half of the data and get its median. And in the textbook, it calls lower fourth and upper fourth. But for us, I'll just call it Q1 for the first quartile, Q2 for the second, and Q3 for the third. Q4 we have also for the and Q2 would equal to the fifth percentile of the data. Okay, and another definition is called interquartile range, short as IQR. This also used quite often. It measures the spread of the middle half of the data. You take the third quartile minus the first quartile. You get the thing in the middle, 50% in the middle. Okay. On the text, it's called force spread. Okay, another descriptive statistics, like a different plot that you can do is box plot. It's a graphical representing of 5 values of the data. So the minimum value, Q1, the minimum value of the data, Q1 of the data, the median, Q3, and the maximum value. And I'll show the whole plot here. Well, it also shows outlier. See here, this is one data point being the outlier, and this bottom line is the minimum of the data. This upper is, well, yeah, this upper is not the maximum, but that's the 1.5 IQR away from the median. sorry, I shouldn't say, but for this particular data, this bottom line would be the, oh, sorry, I totally messed this up. Well, I should say this, yeah, this is the outlier, and this whisker, we sometimes call it whisker, and this box plot is also called whisker plot. And this two things shows the 1.5 times IQR away from the median. And so this solid black line is the median. Something. These two are the 1.5 IQR away from median, and this is the Q1, and this is Q3, and this is an outlier. You can also use the box plot to compare data. See, we had box plot for the first data set we have. And we can do another for a new data set, as here, where the mean is 2.5 and standard deviation is 1.5. When we plot it for this one, we do not have that outlier. So it just shows like this.
I have a question, Dr. Gong.
Mm-hmm.
So the line, the one that is on the box, the top part is the Q3 and the bottom is the Q1?
Yes. This is Q1, this is Q3, and this is Q2, or you can call it median.
That's Q2 or medium, right?
Yes, yes.
And then the top top line is the outlier?
Yeah, this little circle is an outlier for this data set.
Oh, okay.
Yeah.
So, okay. Outlier.
All right.
Okay, thank you.
No problem. So this is just to compare two data sets where you can obviously tell that the median compared to this one is higher and this one is lower, and the shape, the distribution of the data are different, like the interquartile for this first data set, because this is Q1, like the bottom here is Q1, and this is Q3, and what's in the middle would just Q3 minus Q1. This is the interquartile IQR. So this box, and for this one, this is its IQR. So the first data set have a much narrower IQR, smaller IQR compared to the second one. So this is just a way for comparison. Okay, measures of spread. Previously, we actually had one measure of spread already, which is the IQR. I mentioned this one spread narrower and this one spread wider. The spread is another important characteristics. And it tells the variation in the data. The variation in the data tells you whether the data is concentrated right at the mean or it's widely spread out. Concentrated at the mean, or you can say concentrated at the median. Consider this two histogram with the same mean. Well, this one, if you look closely, this one plotted the data range is from 0.5 to 4, and this one, the data range is from negative to more than 10, right? If you look at the spread of these two, well, this one definitely spread wider comparing to this, the first one. Well, it's actually hard to tell from this because, well, when I read the plot, I understand. So this, yeah. So when I read a histogram or read any plot, I will just look the x-axis, like x and y-axis. So this one tells you is from 0.5 to 0.4. I mentioned, and this one is a much larger range. But because they are not plotted at the same scale, so it's hard to tell from this plot. I just put here for easy comparison for you. If I put this two histogram on the same scale, see both are from 0.5, -5 to 10, then you can easily tell that this one is more centered around the mean, and this one is spread out, right? It's much wider compared to this one. And when I generate the data, I use the same mean, but just to show you different spread, and make this two plots. Okay, variance and standard deviation. Well, standard deviation provides us a numerical measure of the overall amount of variation in data sets. And it can be used to determine whether a particular data value is close or far, close or too far from the mean. And it would be always a positive number, or it could be zero. It won't be negative for sure. We compute it, use the deviation from the mean. Well, in this example, we already show like the spread of the data. Actually, this standard deviation, but when I generate the data, I just use a different standard deviation. For the first one, I used a smaller standard deviation, and the second one, I used a larger one. It shows you the variation of the data, right? This one is ranged widely, and this one is mostly concentrated around the mean. Well, here are more detailed definition for the deviation, standard deviation. Deviation from the mean is defined as x is your data minus the mean. That's deviation from the mean. And the sample variance, we use s squared, which is the sum of the squared deviation divided by n minus 1. This is the sample variance s squared, and this is the definition of sample variance. A sample standard deviation, s is the positive square root of variance. If we want to compute this ER, we can just directly use VER for variance and SD for standard deviation. It's quick and easy like this. So this is just a definition. I will not ask you to like do this by hand. You can just do this from R. I think this is the last topic. It's called skewness. Sample data and probability distribution are either symmetric or skewed left or skewed right. Symmetric means they're just like the left and right are just the same. It's like the mirror of the left to the right. If the data is skewed left, then the left tail of the data is stretched out, the left tail from from the histogram, you get a long left tail. And the right set seems cropped off in comparison to the left, right? This right is just looks like it's got chopped off. If the data is skewed right, then you got a longer right tail, and this side got chopped off. So this is the command when I do the histogram. If you notice, I have this min equal to this. This just gave you a name, like a label for this histogram. Okay. So in general, if the data is skewed left, the mean will be less than the median. But the mean is red. It's red in this plot. So this is a left skewed data. And the mean is lower than the median because it goes to the left, right? This red vertical line. Why is that? If you think. Apparently we have more data points here. It can like read the data, like drag the data to the left. So mean is the average of your data. So it will lower the like drag the center of the data to the left. And if you have skewed right data, similarly, the mean got dragged off to the right. So right skewed data, the mean is more than the median. Okay, I think that concludes our first week. So I think today my throat is really burning. So I have to keep drinking water. And when I go through the slides, it could be like a little bit faster. But if you have questions, if something is not clear, like post questions on Blackboard, discussion board. We will have a discussion board. I will get you some folders for the first week. You post question on the week 1. And the second week you post question on week 2, like that. And also office hour. I will hold office hour online next Wednesday. Yeah, I guess that's it for today. And thank you all for joining. And I have to apologize again, really, because of this sudden change. And I see this. Oh, where can we find the website access code? Okay, I will get this. Yeah, one student asked question from the our chat box. I will find this and do an announcement on the Blackboard, because for me, web design is also something new, and I will figure this out and better answer you the question. Okay, and I will stop share here and stop recording. And I recorded today's session just in case people missed it. But for the future, we may or may not record it. It depends. All right, thank you all, and I will see you next week.